As you just said, my name is Justin. I work at IntelliJ at JetBrains on the IntelliJ Scala plugin. You can find me on Twitter as Ebenwert, and that's all about me right now. So you may have recognized the background picture. Who knows it? Yeah, that's right. It's the Scala tooling ecosystem. Different names have been attributed to it, like the Scala type system or Garden of Earthly Delights, but I have it on good sources that this is the original title. So the purpose of this talk is I want to give you like an overview of some tools inside and outside the Scala ecosystem that have the potential to improve your workflow, and under what circumstances they would have this potential. I'll give plenty of examples on that and muse about where this could lead. And I'll do this sort of in the structure of a Hegelian dialectic with thesis, antithesis, and synthesis, and illustrate it, as you see, with Hieronymus Bosch and lyrics by Daft Punk. So the thesis is fork it, make it, do it, makes us harder, better, faster, stronger. What do I want to say with this? So forking, I'm using the term quite liberally, not just forking a code base, but like creating new tools for the same purpose as other tools we have in the ecosystem. So while forking may make the whole process of software development harder to learn, it will also enable us better and faster ways of doing things, and thus making the ecosystem stronger. Throughout this, I'm going to assume some basic familiarity with most popular tools. So let's zoom in a bit on some things that tooling help us with. This is an incomplete list, but I'll pick out some of them, like learning, experimenting, editing code, exploring under code, dependency management, publishing, versioning. First step, learning and experimenting. I think this is a very important and maybe sometimes undervalued part of the whole development experience, because fast feedback loops, when we try to learn something, they improve the whole experience. So there's different ways of experimenting. The classic is the REPL, the read eval print loop. It's there's a REPL coming with Scala, but it's not very advanced. So there's a better one called Ammonite. It's Ammonite is a whole Scala scripting suite by Haoyi Li. It includes a REPL with various features such as history search, syntax highlighting, block input, undo, redo, artifact imports. So you don't even need a build tool for that, and many others that I don't even know. A different approach to a REPL is a worksheet. I'm giving an example of Scala here. It's an online worksheet. So with a worksheet, we have like just a piece of code that is persistent. So unlike the REPL, we don't scroll up and down around. With a full editor instead of line by line. Scala here is SBT based, and here in this example I'm using it to experiment with the GigaHorse library. So I'm just gonna go and download the page I'm working on, and here you see the output, the direct output of the evaluation of this file. So another approach is the notebook. That's actually my favorite. I'll show you Jupyter here. So like a REPL, the notebook has a more persistent state, and you update it one input at a time. So here I'm importing something. Jupyter Scala notebook is also based on Ammonite. So you get most of the features of Ammonite, but you also get these cells that are editable, so you can update them and experiment around with them and have the output directly in front of you. So this kind of interface typically also includes some graphical output, which makes it popular with data science, especially for Spark, for instance. So here I'm just making a kind of a histogram of a string. What's missing from this, in my opinion, is like integration with a full project. So I'd ideally like to be able to run a notebook on an IDE project. The notebook interface was in fact pioneered by Mathematica, and Mathematica uses it for its documentation as well. So here you see extensive documentation. I'm just going to zoom in on one function, the nest function, and you see here there's examples, and I can play around with them, immediately change stuff, and see how it affects the output. So here I discovered a Sierpinski triangle in the neat example section. So I'm just gonna go ahead and import a picture of Václav Sierpinski, scale it down a bit, and insert it into this example, and create a Sierpinski triangle. You're welcome. In my opinion, this is the gold standard for documentation, and I wish we had something like this in Scala. So editing code is not just typing as fast as you can, so you need a bit more than completions. You also want to understand what's going on or how this code is structured. So another example from Mathematica, I'm gonna input some complicated mathy formula with a square root and a sum, and Mathematica immediately, as a computer algebra system, prints it into a math formula, and you can see here at the press of a button I can transform it between different representations, and I can also use some functions on it to transform it to the input form or the full form, which is akin to Lisp S expressions, and even as a tree form. And this is very helpful because in Mathematica you have very powerful pattern matching, more so than in Scala, which allows you to match on the structure of this expression. Something completely different, low level, which I discovered. So in InfoSec, often you will decompile some machine code, get long assembly lists that are just lists of symbols. And a nice way to display them actually is like this tree where the jumps will go in the code. And I think this is a nice representation. For higher level languages like Scala, this might not work as well because we have more involved constructs. But one attempt to do so is the code bubbles interface. Actually an IDE, it was originally created a while ago. As far as I know, it's still being developed a little. And as you can see here, it allows you to navigate from one function to the next, not by just opening the other function in a new window and jumping with a cursor, but actually putting it side by side. So you are able to actually cross-reference the code you are using with the use point, where the point where you use it. So that's a more semantic way of exploring code. And I think if this was implemented in a more usable way, so this IDE has some fallbacks like drawbacks. It can't even import a Maven project as far as I can tell. Then this could make files obsolete in some sense. Compiling. So arguably compilers aren't really tools as such, but they are the interface that stands between you and a working product. So I guess that merits a few slides. So here's an actual fork of the Scala compiler of lightband Scala is type level Scala. It's more focused on bringing new features and fixes quicker to people who want to work with them, but otherwise tries to maintain binary compatibility with the main Scala and the Scala ecosystem. Another more experimental thing is the reasonable Scala compiler developed by Eugene Burmako at Twitter. I don't think that's him. It's more experimental. It tries to figure out like a reasonable subset of Scala that you can compile quickly and find features which have the largest compile performance impact. Not a compiler, but a compile server is Bloop. So it's a thing that runs independent of your build tool and maintains a hot compiler, because one of the main performance impacts you can do with the Scala compiler is not having it warmed up, because the JIT compilation performs all kinds of optimizations, but only once it's running for a while. We also have this in the IntelliJ Scala plugin as a compile server. Bloop aims to be a bit more general, usable from any build tool. So speaking about building, one of my favorite subjects, since I have worked long on integrating SBT into the IntelliJ Scala plugin. So it doesn't involve just compiling. We can use plain compiler or Bloop for that, but also managing dependencies and putting everything together into artifacts which you can actually release. So I looked around what kind of build tools there are, and in general developers don't seem to be very happy with their build tools, as evidenced by the fact that there is basically an ache for every letter. Yes, these are all build tools that someone has released somewhere. Yeah, it's missing IAche and UAche or something. And take for some reason. And don't think any of these are actually for Scala, but we have a few in the Scala land as well. So in the right corner we have the classics, the classic Java tools and Maven, Gradle. And in the left corner are more Scala-focused tools such as SBT, CBT, and recently Mill. Contenders. These are tools such as Bazel, Pants, and Buck by Facebook. I get it. That are more focused on building from sources in a large company-wide monorepo. So one of the concepts of Bazel and in extension Pants and others is that you're supposed to split your build in lots of little tasks, and each task fully defines its input, so it sources the tools it uses and so on, and the environment, so that in turn the outputs can be cached, and if the inputs don't change, you can use the outputs, so like a package that you have compiled with reasonable certainty that it will be correct. The Scala-focused build tools, CBT and MIL, they follow a bit slightly different ideas, but they both have in common that they try to make the configuration simpler relative to SBT by allowing you to write it in plain Scala and not learn DSL and Scala on top of that. So minimize the concepts that you have to learn. In CBT, the caching is sort of responsibility of individual tasks, whereas in MIL, the targets in MIL is sort of inspired by Bazel here. It tries to have targets which you can fully specify and which the outputs will be cached, but you can also have uncached commands. MIL has a inspectable task graph by default. I think in CBT this is not yet the case. Let's look at, we have the ingredients to write code and build code. Let's look at creating a library. So I'll just show a few tasks involved in doing this. One major point is publishing. I looked at how it's done in Cargo, and this is surprisingly simple. I just generate an API token and gonna go copy that. Yeah, go ahead and try to use this to publish and under my name. And I'm just creating a new project here with a Cargo tool and looking at it there. Cargo uses a declarative format, so for some reason they don't seem to need a Turing-complete build language. I'm trying to commit this and publish it, and it gives me an error. It's still missing a little bit, just these two fields, namely description, fork it harder, make it better, and license. I think WTFPL is quite appropriate. And let's try to publish this again. Is it ready for publish? This seems to have worked. And let's just check out crates.io, and my library has actually made it there in under 2 minutes of real time. So in that time, I don't think I could create a Sonatype ticket. The publishing process in Elm is somewhat similar. There's a few extra steps because it requires you to write documentation and whatnot. I've already done this here. But Elm gives you a little more. So I have this library fork it, and I want to just add another function to it. I'm calling it better. Sophisticated algorithm. Save it, try to, yeah, Elm has this one tool, Elm package diff. It actually gives you, it analyzes if your public API has a major change or a minor change. So here it showed me it was a patch change because I hadn't exported this function. I save it again, and now it's a minor change. I can automatically bump the version. So the packaging tool enforces semantic versioning. And you see it bumped it up there. Now I'll just go ahead and commit this stuff and try to publish again. Okay, it tells me I still have to add some tags, okay. But helpfully it gives me the code to paste right there. Another publish, and success, I have published a new version. So I would love if I would have this in Scala as well, some way of diffing APIs. Of course, it's more complicated. What I'm trying now, I remove the function again. That's a breaking change, so it detects a major version change. And I just go through the same process again to publish the update. Yeah. I have to verify this just to make sure it's really there. Yeah, good. Another one of my favorite subjects is dependency management. So that's one thing that we have in Scala world, in Scala lang, is Kaeser, luckily, which makes the whole resolving process much faster, as you can see here, than you're used to with Ivy. It is, in fact, designed to be a drop-in replacement for Ivy, and it works almost, except for there's some minor differences that has so far blocked using it by default from SBT. But all the new tools like CBT and Mill use Kaeser or something like it. Something completely different. Nix is actually designed as a package manager for OS packages. It has some concepts that kind of remind me of Bazel in that you have to specify the exact versions of the dependencies you're building against, and you again build everything from source, and by doing so you're able to cache the outputs, and other users, consumers of whatever package you published, are able to consume this from a cache. But unlike Bazel, it has a more project level granularity. But I think some people have already used it as a basis for package manager. It seems to be popular in Haskell community, but maybe somebody can tell me more later. So we have all these things that work with publishing sources that seems to sidestep a lot of the problems we have with publishing binaries in JVM typical ecosystems. So wouldn't it be great if we could just publish to GitHub and resolve from there? So yes, we actually can. There's this neat service called Jetpack, and all you have to do really is add the resolver and add a library corresponding to a GitHub repo at a certain tag or commit hash, and it will build it for you. I'm not entirely sure where the limits for this lie. I'm sure there's some SBT builds that are too complicated to practically be resolved via GitHub, via Jetpack. So that's enough forkery. Let's move on to the antithesis. More than ever, hour after hour, work is never over. Yeah. So as I mentioned, having all these different kinds of tools that do more or less the same things a little differently makes things harder to learn. So, and you could make the point that the effort is better put into improving established tools. And indeed, there is effort being put into that. Just given, for instance, the Scala compiler, currently maintained by Lightbend. Looking at the roadmap, we have things like they want to improve the compiler performance. I think also Jorge has talked about how he's improving performance in Zinc just a few hours ago. Collection simplification, that's more part of the library, modularizing the standard library, and general user friendliness. SBT is, as you probably know, used by the majority of Scala plugins at this time. It's been around quite a while, since 2009. And there is a huge ecosystem of plugins, so you're already able to do lots of tasks, whereas with a new build tool, you might have to write this on your own again. They too want to make contribution easier, and that involves things like documentation and code and test organization, labeling issues, and so on. And yeah, this is a thing that is, you could subsume under polishing the product, which many new products have an issue with. They don't have a lot of polish. That they might have good basic documentation, but maybe not so deep that you can get into all the details. And of course I have to talk about my product. Well, not just my product. There's 8 other people on the team. It's been around since even longer. First commits date back to 2006. And we have a lot on our roadmap, including, of course, fixing various error highlighting issues that have plagued many of you, I'm sure. But also making it easier to get started in the first place with a one-click installer. And also making contribution easier and make it easier to extend it with your own code. Just to get an idea, how many of you use IntelliJ Scala, or how many don't? That's okay. That's 2. Yeah. Good to know. Thanks. And how many knew that it's open source largely? Yeah. Okay. A few didn't, but yes, you can look at the source and fix all the bugs yourself. What's the fun? Yeah, right. It's much more fun to complain, I know. I like to complain. This whole talk is about complaining that our ecosystem isn't good enough. So finally, this brings us to the synthesis or convergence. Yeah. So it goes like this: fork it harder, make it better, do it faster, makes us stronger. More than ever, hour after our work is never over. What am I saying with this very nice lyrics? So I don't think there is just the choice between new tools and old tools to maintain, but instead we can try to work on integrating them better. So if we agree on tools and styles and most importantly protocols, we can integrate things to leverage all the work we've done on our old tools, and as well take advantage of new ideas. There has been some work going on, some collaborations between various teams. For instance, we've coordinated with the SPT team on releasing IntelliJ and SPT 1.0 so that we can support it more or less the moment it came out. As well as recently I've been working with Jorge from the Scala Center on the build server protocol, which will be presumably available in the IntelliJ Scala nightlies a week ago, or more realistically in 2 weeks. And of course the Scala Center, which is all focused on improving Scala tooling, has collaborated not only with us, but also with the SPT team, with the Zinc compiler team. And also more recently, the Jump-Pretty has initiated the LSP SDP working groups. That means Language Server Protocol and Scala Tooling Protocol working groups, which brings together many people working on tooling in the Scala sphere, in the Scala ecosystem. And we're actually going to have a meeting tomorrow. As well as on Friday, there's going to be a Scala Tooling or Contributors Summit, where many of us will be talking to each other and trying to coordinate a way forward. Now I want to have a look at a few projects that further this integration. So one way of integration is the language server protocol, and early level project is Metals. It's a Scala Meta based language server, and it brings you a few basic IDE-like features to any editor that supports the language server protocol. Do you know the language server protocol? Yeah, a few. Yeah, it's a protocol initially developed by Microsoft for the Visual Studio Code editor, and it's been quite successful in attracting many implementations for various languages, because it makes the problem of integrating editors with languages somewhat easier, because you don't need specific support for each editor language pairing, but instead can just implement the support on the editor, the client side, and on the server, the compiler or language server side. Likewise, Dotty already comes with a language server baked in, and so also offers these basic IDE features in any editor that can support it. So the build server protocol tries to extend the language server protocol in ways that allow editor or IDE to integrate with build server or build tools such as SBT or Bloop, which I mentioned earlier. And yeah, I've been working on this together with Jorge from the Scala Center for a bit. And yeah, I mentioned I hope to have this merged in a few weeks or so. And if you are a build tool developer in some sense, then maybe talk to me about getting this integrated into your own tool, so that you can take advantage of IntelliJ as an editor and with direct built-in support for your tool. And this is, of course, not all the integrations we have, but as an integrated development environment, IntelliJ, of course, includes many integrations for many tools such as, or languages such as SBT. More recently, Ammonite scripting is supported. In the ultimate version, we have support for Play, Scala.js, Akka. Spark support is coming soon. And as I mentioned, the experimental build server protocol. So that's it for me. What about you? So I assume you might not have the time to be working on tooling all the time, because you have actual business problems to solve if you're not a tooling developer. But maybe you can consider how much time you're using to work around limitations of the tooling, and if you or your company, if it doesn't make sense for you to invest a bit in this. I mentioned many of the established projects are trying to make contributions easier, and I think we'll be all happy to talk to you if you want to contribute to support changes in a specific direction. So get in touch, work together. Thank you, that's it from my side.